Very good and warm welcome to you. Good afternoon, it's Dean from Maverickstar Observatory. Guys, in this video I just wanted to take it right back to the beginning, have a look at some of the stuff that we've gone over the last 5 or 6 years, just very briefly though. Before I do, huge thanks to those few people that are supporting our efforts here at the Observatory. You know what we're trying to do here, and I know a lot of people don't realise that, is make the awareness of a very rare anomaly. And as you can see from the top of this chart, you know, if you go back 0.78 million years ago, 780,000 years ago, that was the last time the Earth went through a completed magnetic reversal. It is really important because we don't have any data of that recorded incident. We don't know, other than the fact that the Earth did go through a reversal back then, we don't know what took place as it was doing so. What we do know is that when the magnetosphere starts to weaken as a result of the poles migrating, we have more inbound cosmic radiation. I just want to go over some of the things related to this in this video for use, and a little bit later on at the end of the video, you know, we'll ask if you wouldn't mind supporting our efforts here so that we can get more people prepared for the event which is shortly to come in our lifetimes. This is going to happen in our lifetimes. We anticipate now, just over 10 months away, we will see significant changes as a result of our Earth going through a change. And I'm just hoping that you want more people to know about this in the same manner as which I do, because at the moment it stands as 98.5% of the Earth's population are completely unaware, first of all, that the Earth is going through a magnetic reversal. Secondly, that most of the climatic events we see taking place today is a result of that magnetic reversal, as well as a couple of other little anomalies that are taking place, which we will cover in this video. Okay, let's get on with it. So here's a chart of how the the magnetic reversals have gone for just over 5.25 million years. You can see that we've never gone really as long as what we have in the recent years without a magnetic reversal occurring. You know, on average, it used to go through a reversal every 300 to 350,000 years ago. And we get this data from the Atlantic Ridge in the mid-Atlantic Ocean. What we find is when we look at the solidification at either side of the undersea volcano around the ridge area, we see the seafloor spreading, solidify. As it solidifies, it's trapping the magnetite in its polarity at that point in time. And when we run magnetometers over there, very sensitive ones, we can see that over a certain space of time it has reversed many times. Well, if we measure the rate at which the seafloor is spreading and go back in time, it gives us an indication as to when that event took place. So first thing we know is the age of the event. Second thing we know is that it has happened many times before. We also know that it has happened more frequently than what is happening right now. And that's why, for this reason, I say that this magnetic reversal is unlike any we have ever experienced, because for some reason the Earth has took a lot longer to go through the reversal. Now, I've supposed the question, because I think it has to be put on the table. Does this mean that something is solidifying in our core which is stopping that magneto working normally, where we get regular reversals every 300 to 350,000 years? I think it's a valid question to put on the table, and that is one thing we just don't know. But if it is unfortunate the case, and we are seeing early signs of solidification to our core, that will shut down our magneto, which allows us to have the benefit of magnetic dipoles, or magnetic north pole and magnetic south pole on our planet. But more importantly, it's also what runs our magnetosphere. It's what generates our magnetosphere, and that's what we don't want to lose, because if we lost that, we would lose the upper atmosphere. NASA have got a term they use for this. It's called sputtering. It's where the upper atmosphere is stripped off by ions coming off our sun and into our solar system from our galaxy and other galaxies. And you know, if we look at Mars, we know on its terraform it had water on the surface, it also had an atmosphere, but more importantly, what we know is it had a magnetosphere. But one thing we know today, it no longer has a magnetosphere, it no longer has magnetic poles, and it no longer has water on its surface, neither does it have an atmosphere. So they are all linked together with the core of Mars's magneto shutting down at some point. Another thing to note, it no longer has active volcanoes like we have. So at least one thing we can say is, well, we have still, on average, every day, 24 active volcanoes in eruption. So we know that there is still molten core in our Earth. It hasn't solidified to the point where it shut the magneto down. So that's a really good thing. But, we don't know what will be the effects of a short-term or even a prolonged short-term result that will occur to the Earth when it loses its magnetosphere. We depend on this to stop us getting cancer. So if we have even a short reduction in the field strength weakening to the point where about 10% even, cancer rates are going to boom. We know that they're related to cosmic rays and other forms of radiation coming from the upper atmosphere. We also know that it changes cardiac arrhythmias. So more heart attacks should be expected at a time where the magnetosphere is collapsing. Just want to go back to what I said at the beginning of this video. We're probably 10 months away from seeing a rapid decay in the magnetosphere due to those poles crossing a distance of 40 degrees over the northern hemisphere and entering the weak field lines, and therefore migrating a lot faster. This was experiments that we've done here at the observatory, and witnessed that when magnets in the vicinity of a compass are rotated, what happens is the compass needle will migrate a distance of 40 degrees on the compass, and then at that point it snaps, it goes over to the south pole. And we're probably 10 months away from probably seeing something similar happen with our dipoles on our Earth, and as a result of that we could see an increase in the climatic events that we've seen over the last 30 years gradually build up. One of the last things I want to do is slow boil a frog. I don't want us to become complacent as to what is happening on our Earth. It's really important. A lot of world governments and organisations are saying that this is a direct result of human beings putting carbon into the atmosphere, generating a warming effect. It couldn't be any further from the truth. If we've got time in this video, we'll quickly have a look at the evidence to support or rebut that conclusion that they've come to. It is highly likely, as we have seen in the last 30 years, a rapid uptick in the speed of migration to do with not only further depleting of the magnetosphere, allowing more cosmic rays in, but as a direct result of that further acceleration of the magnetic pole. It just is not coincidentally, I believe, it's more synchronously linked to that fact that it goes back 30 years. As that has happened, or began to happen in the 1990s, what we started to see and hear a lot more about was dramatic climatic changes to our planet globally. So let's have a look at some of the other things that we've got. So I just briefly want to go over this flow chart so you get an idea of how two of these anomalies that we're living with at the moment are having an effect on our Earth. So starting with the grand solar minimum, this is to do with low solar output or low sunspots that we see on the disk. This leads to a weakened heliosphere, which is a bubble like our magnetosphere that protects our Earth, but only the heliosphere protects our solar system. If you imagine a bubble stretching beyond the outer planets of our solar system, well, all that will help push off intergalactic radiation. Again, we've got that will lead to, as it shrinks, it leads to an increase in cosmic rays in the Earth's upper atmosphere. The magnetic pole reversal is doing the same or leading to the same effects. When a magnetic pole goes into reversal, this leads to a weakened magnetosphere similar to the heliosphere, and this the same as the heliosphere weakening, leads to the same effect. It leads to an increase in cosmic rays in the Earth's upper atmosphere. Having an increase in the Earth's upper atmosphere of cosmic rays, what happens is we get cosmic rays mixed with the upper atmosphere particles that allows water vapor to condense on forming and in doing so forms more water droplets, so we get more precipitation in the jet streams. Water droplets enter the jet stream, increasing the mass and velocity of the jet stream, in turn changing the behaviour, i.e. polar jet streams mixing with subtropical jet streams. And as we are now seeing, even at the time I'd done this flowchart, we're now seeing something else, a new anomaly, where we're getting over the northern hemisphere the subtropical jet stream mixed with the southern hemisphere subtropical jet stream, over equatorial exchanges between the two subtropical regions. This is a new anomaly that even the mainstream organisations have not come out and told the public about. You know, this is further escalation as we go down this rabbit hole and these things continue to multiply. This is further effects of climatic increases in these dramatic changes that's delivering floods, early forest fires and droughts. Again, all this leads to our crop production, and we could never be at a worse time than what we're faced with now, for not just the fact we're going for a solar minimum or a magnetic reversal, or we're on a world where a major war has broken out with one of the superpowers, and it is clogging up food leaving Ukraine and other countries, and there's been export bans, import bans. This could not be happening at a worse time, and yet the mainstream media are just dusting over it lightly with a feathered brush. It's shocking to be in a time and see so many people not care about the planet in so many ways, and not understand what is happening with the planet in the simplest of terms. Now we're looking at a space environment overview from 2014. I've tried my hardest to get one recent with the same outlay as what we're looking at here, so that you can see from the earlier ones that I've showed what is taking place. But if we just look at the top three columns and focus on the right, because where we see that black line increasing on the top, which is the monthly smooth sunspot number, we know that that is solar cycle 24. And the important thing about this is go down to the third line down, and we're looking at the cosmic rays. Now you might say, do you have proof of cosmic rays on the increase? And certainly we do, and this chart shows that. But there's something more important I want to point out here that nobody is explaining to anybody about. Generally at solar maximum we're in the middle of one of these humps, and what usually happens at solar maximum is it pushes out all the cosmic radiation to a lower level. But if we look at solar cycle 24, we can see that the cosmic rays have increased even during a solar maximum. It's shocking to see this. You can go back to solar cycle 23, have a look at maximum, you'll see that the line flattens out and it goes into negative territory. Solar cycle 22 shows the exact same thing, and we can just see solar cycle 21 beginning at the left hand side. We can see that there's no pushing through during solar maximum, or even at a stronger part of the solar cycle, cosmic rays going into the positive territory like they are in solar max at solar cycle 24 on the right hand side. So yes, cosmic rays are definitely on the increase. Remember, they cause cardiac arrhythmias, they also cause cancer. So don't be surprised if over the last 10-15 years we've been starting to see the numbers gradually increase in those two major illnesses. Now, in a very brief look at this. This is CO2, because the reason why we're looking at this is because this is what they're telling us that all these changes are caused through, you know, CO2 going into the atmosphere, creating global warming, and it's all man's fault. But if we look on the left in blue on that disk, you can just see a very thin sliver. That represents not just the CO2 that mankind has put into the atmosphere, but it also represents the oceans, gigatons, and land gigatons that have gone into the atmosphere. But nevertheless, in our atmosphere, it amounts to just 0.4%. If I dropped a little bit of orange cordial in your glass of water to the tune of 0.4%, do you think you'd taste that? Probably not. But what about if I said then, well, look, let's, like the organisations would say, well, it's man who's done it. Well, in red on the right hand side, we've put the man-made CO2 that's gone into the atmosphere on the right hand side there, and you can see it's marked in yellow on the pie chart. That is 0.012%, right? The rest is naturally put into the atmosphere by the land and ocean reservoirs. And you know, this is what they don't show you, because they would never convince any audience if they showed you, you know, in its basic form like I'm showing you here, how much CO2 man puts up into the atmosphere. One thing we've got to understand about this is that naturally when we're in an interglacial period like this, is that, you know, more CO2 will leak into the upper atmosphere. But when it starts to go back into a glacial period, and you know, from the videos that I've been doing, we are returning back into a glacial period. In fact, to a lot of people's surprise, we've been returning back into that glacial period for the last 6,000 years. I've showed you the Milankovitch cycle, which is responsible for the cycles of every 100,000 years, where we go slightly into a glacial period. Well, we'll go into a glacial period for about 98.5% of the time. We're in an interglacial period for about 5% of that time out of the 100,000 years. You know, it shows you that when we go back into the glacial period, the CO2 stops being emitted into the atmosphere. In other words, when the climate starts to go back into a glacial climate, you know, so does the CO2 levels drop. It takes around about, I don't know, 70,000-80,000 years to reduce CO2 levels back to a normality. But it's not uncommon at this point in time for CO2s to be slightly higher than normal. And you know, again, if this fact has been exploited. They won't even talk about the last glacial period. Yet it is widely known to most paleontologists that we came out of a glacial period only 12 to 15,000 years ago. We're in the end of a glacial period, interglacial period, and we are, returning back into a glacial period. We are currently at the end of a glacial period. So, you know, this is why mankind has expanded, because the climate has allowed him to do so. If I showed you the chart, the temperature chart of the Vikings when they landed on Greenland, they was only there for a short period of time, and when they realised the temperature went cold, they could no longer sustain a living there. They shut shop and got off the island. Because it was almost inhabitable at that time. You know, this shows us that when only a small amount of temperature changes over a given continent, then it is the difference between being able to sustain a living on there or not. You know, these fluctuations, as I've showed before, can range within less than 10 degrees plus or minus Celsius. So it gives you an idea of what we're up against. And you know, of course, I've got to mention this last anomaly before we wrap this video up. So here we are. If we look at the right hand side of the dark line running through the 0 degrees Celsius mark, we can see where we are. We're at the end of a glacial period. We know that they don't last longer than this. We're in fact 6,000 years returning back into a glacial period. You can see that we've got 4 previous interglacial periods. We can also see that the CO2 is starting to rise at the peak of the glacial interglacial period. But look what happens once we get past it and that red line goes beneath the black line at 0 degrees. So does the CO2 start to fall. Why won't they show this on mainstream media? Why is there no scientist with the facts showing this? Why do they always want to use Michael Mann's hockey stick version of temperature going back only to the 1900s? Well, simply because since the 1900s it is clearly provable that temperature has moderately crept up. Well, it shouldn't come as a surprise as we're in a glacial period, but we are coming towards the end of that and things may have already started to shift. But I just wanted to show you, look, the horse doesn't lead the cart doesn't lead the horse leads the cart, and you can see that it is only after temperature has gone up that CO2 goes up. What they're saying is that the CO2 is going up after the temperature's gone up, and that's not the case. You know, we're using records going back over 400,000 years. They're using records going back only 120 years. If you want a more accurate prediction of climate on this earth, do you think we should be using a record that goes back 120 years, or a record that goes back and also includes the other 4 glacial and interglacial periods that we've been in, extending 450,000 years into our past? You tell me in the comments section what you would like presented as an argument, as evidence, and what would you prefer? You know, evidence that is supported based on 450,000 years, or evidence that is supported on just 120 years? Let me know in the comments. You know, again, is there any evidence to suggest that the jet streams have changed on our planet? Well, you do some work here. I've put where the jet streams should be at the bottom of this image of the Earth. We're supposed to have a jet stream, which is the polar jet at 60 degrees north, and we're supposed to have the subtropical jet stream at 30 degrees north, and that is the same for over the equatorial region in the southern hemisphere of our planet. You tell me, do we have 2 jet streams in sight on our planet? And if you go over to North School, you'll get an image of today. What you're going to see is not just 2 jet streams dominating our planet, but you'll also see that in some places they fragment, go over the equatorial region and dip into the subtropical region over the southern hemisphere. It's incredible. You know, again, no mainstream mention about this. Let's just keep people focused on the Ukrainian war, because that is a massive distraction for a lot of people, and they are using that for multitudes of reasons, like stealth taxing you. You know, not now are they happy just to take trillions of pounds off us for CO2 carbon credits and carbon taxes. Now they're taking, you know, more money from, you know, supporting the Ukrainian war. You know, in other words, supporting the death of many millions of people right now. You know, the information war began years ago. They went after us before Christmas. How can you give people strikes for talking about the climate just because they've got an alternative view to what your mainstream organisations want to push out so that they can raise taxes? They went after us, they demonetised us, stopped us putting adverts on our videos. You know, they give us a strike for talking about COVID vaccines. You know, I'm qualified in biology to talk about that. I'm qualified in climate and earth science to talk about this, and yet I'm the one who's getting struck for it. Why not give those people like Al Gore a good strike? Because he needs not just a strike, he needs a lightning bolt put up his arse, because he has been the one that has cost us all heavily individual in our pockets to this day because of his global warming predictions. Let's just put it to the test. Is there ice caps over the northern hemisphere? Yes, there is. Is there snow still falling in the skies in the winter months? Yes, there is. So how can it possibly be that we would not have these things by 2014? You know, they give this guy a Nobel Peace Prize for that, just like they're given these Nobel Peace Prizes out willy-nilly to anyone these days. This is the world in which we live. those that deserve support won't get it. Those that least deserve the support will get everything, and on top, a cherry in the term of a Nobel Peace Prize. Absolutely, absolutely amazing times in which we are living in. And it makes us feel sometimes that we're in biblical times, because people would rather believe lies in this day and age. They would rather watch pranksters than a scientist explain the true nature of what's going on their planet. They would rather be transfixed to the TV that is titillating them with the war in Ukraine. That's the world in which we live today. It could never have been a worse place for humans to live. You know, as it says in the Lord's Prayer, you can make a heaven on earth, or it will be as a heaven or a hell on earth, you know, or something along those terms. I think you gather what I'm on about. As it is in heaven, so shall it be on earth. I think that's the one at the end. I think I got it right in the end. Anyhow, it's a shambles, guys. It's a shambles. It's not just the climate, it's not the jet streams, it's the lies about the amounts of cosmic rays coming in, causing cancers, causing cardiac arrhythmia. You know, it's the lies about CO2, it's the cover-up about the return into the glacial period and the lack of work that they have done to protect civilizations. You live in a city, you know what, you can forget it, because if the climate stays fixed in a cold region of your city, it's going to be like that probably for a very long time. And you know, we've seen it. We've had examples in Texas last year where the grid was knocked down, affecting over 100 million people. That's the sort of thing we're going to start seeing more of. And those disbelievers will have no choice but to open their eyes to the truth at some point. Yeah, it's a real sad time that we live in. Just before we end, I'll end it on this last note. I'll leave you with this one, guys, and I'll just ask this question. Is the magnetic intensity and the magnetic poles having any effect on the climate of our planet? On the left top, we've got temperature. The more purple it is, the more colder it is. On the top right, we have the magnetic intensity. You can see that this is 2020. And then on the bottom left, we've got just a visual intensity of that field strength. The darker red, like is over Russia, you can see is around about 65,000 nanotesla. So I asked the question, is it a coincidence that where the temperature is colder on Earth, it just seems to be where the highest intensity is? And if the poles are migrating, what does that say? Where will these coldest temperatures be? Well, common sense should tell you that these temperatures will be where the highest intensity is, or where the magnetic North Pole finally settles. It looks for now that it's going to be in central Russia. And then, you know, you can't, have it any other way than what we've got. Okay, let's look at where the temperatures are warmer, where the arrows are indicating. Well, these are the least intense areas of magnetism, and these are the warmer regions on our planet. So, you know, I ask you the question, is this a coincidence, or is this accurate? Guys, I really hope you got something out of the video. There's a link down there. It would be amazing. You know, it is becoming soul destroying, really is, that, you know, we have so many people view the video, we have so many subscribers, and yet so little people are putting an effort in here. You know, we have put an immense effort in. We've not made ourselves rich by any stretch of that imagination. That would be a dream, but, you know, we're not there, and nowhere near there. You know, if we can hope for a bit of support from a few more people, then I guess we're not in a bad shape, and we can continue doing what we're doing. Guys, have a great evening, as always. Bye for now.